Hello my dear students, let us discuss about osmosis. See, we are discussing about solution chapter and especially about colligative properties right now. So colligative properties is one of the most important topic from this solutions chapter, okay? And so we have studied RLVP, relative lowering of vapor pressure, and the next we studied elevation in boiling point right now, and we have solved some questions also. And this particular session we will be discussing about osmotic pressure. So what exactly osmotic pressure? And first of all we need to study about osmosis. What is this osmosis? Osmosis or osmotic pressure we will study once after understanding this osmosis. Okay, so this is a process of spontaneous flow of solvent molecules from low concentration to high concentrated solution. Okay, so what I am saying, the spontaneous flow of solvent molecules from low concentration solution, or I can say dilute solution, to high concentrated solution, high concentrated or dilute, and this I can say concentrated solution, okay, through a semi-permeable membrane, through a SPM, semi-permeable membrane. So this SPM, okay, this is a special type of membrane which allows only passage of solvent molecules but not the solute particles. Okay, it will allows only solvent molecules. Okay, so for example here I am drawing a rough diagram for understanding of osmosis. Just look at here. See, I am just taking these. Okay, now in this container, let us say there are two compartments separated by this SPM. What is this? This is SPM, semi-permeable membrane. Okay, so now here I am taking dilute solution, okay, or I can say solvent, okay, and here we can say concentrated solution. So now what happens? So this semi-permeable membrane allows passage of solvent molecules only. From way to way this process happens, from this low concentrated dilute solution to concentrated solution. So this process is what? So this flow of solvent molecules from here to here, low concentrated to high concentrated, dilute solution to concentrated solution, I can say osmosis. What is that? Osmosis. Okay, and it is a spontaneous process we are saying. Okay, now you need to understand what exactly osmotic pressure. The driving force responsible for this process is considered as osmotic pressure, or in more clear manner I can say here using this like diagram. See, here we have only solvent particles, let us say, and here we have solution. So it means here we have only solvent, means it is low concentrated, and here we have some solute particles, means it is high concentrated when we compare with this right now. So now what happens? The flow of particles takes place from way to way. The flow of solvent particles from here to here takes place. From here to here solvent molecules moves right now spontaneously. So when they are moving here, we know this both container, the external, the outside pressure we can say atmospheric pressure. So it will be same in the both cases right now in the initial. Okay, so now when these solvent particles are moving from here to here spontaneously, some pressure is created in this container, this side of container. So now what happens? So the this, if I place it anything here, if I close it, the expansion takes place due to increase in the pressure right now. So now I am saying what I am doing is I am applying some external pressure, let us say pi amount of external pressure I am applying on this solution side. What happens? So this pi external pressure, if that applied pressure and this the pressure created by this osmosis process are equal. So what happens? Flow of solvent molecules stops right now. So I can say the minimum external pressure that is applied to stop this osmosis process is considered as its osmotic pressure. Okay, what I am saying, the minimum external pressure that is applied on solution side I am writing, okay, on solution side to stop osmosis is considered as or is called as osmotic pressure. Osmotic pressure, I am writing the symbol pi to indicate this osmotic pressure. Hope it is clear. Now what I told you, if applied pressure is equals to the pressure created by the spontaneous flow, that is P applied is equals to pi. It means the osmotic pressure created by the osmosis process and this applied pressure which is indicated by pi only, just consider both of same. If they are equal, so what happens here? No flow of solvent molecules takes place. There is no osmosis process. No osmosis. It means osmosis process takes like stops right now, because applied external pressure and pressure created by this osmosis process is equal. It means no movement of solvent molecules from any of this side. Now what happens if this P applied is less than pi? It means the pressure created by this osmotic process, I am saying pi, and P applied is this external pressure, let us say P applied, I am saying this external pressure. If P applied is less, in this case also spontaneously flow of molecules takes place, solvent molecules from here to here takes place. It means osmosis takes place. But if I applied P applied, this external pressure we are applying on the solution side is greater than pi, whether, tell me now, in this case osmosis takes place or not? No, osmosis will takes place, but that will be in the reverse manner. From where to where the pressure applied is more now, it means now pressure is applied more than this osmotic pressure right now. So now solvent molecules will flow from here to here. So in this case I should call this as reverse osmosis, RO I am saying, reverse osmosis. Okay, so using this technique, this reverse osmotic technique, the water purification of water is taking place. Like RO water plants we will be seeing now in our markets and all. Okay, so what it is happening there? So they are using this reverse osmosis process. What they will do? See, simply osmosis means flow of solvent molecules from low concentrated to high concentration takes place right now. So now what they will do is, wherever they have impure water, okay, that salt water, whatever it is, okay, so they will apply extra pressure on that side. Now what happens? The solvent molecules, it means the water molecules from that impure solution, that impure water along with the salts, so salts and all the other things will minerals will stays here only solvent molecules. It means what? The pure water from that impure water will goes this side through this osmosis, reverse osmosis process. This is how the RO filtration takes place. Hope it is clear. Now let me move forward with few other things here. Okay, so now here you need to understand this osmosis is there now, this by osmotic pressure, okay, that is directly proportional to molar concentration of the solution. If more is the concentration of solution, more osmotic pressure it will exhibits. Okay, so now again pi for a particular solution for a particular concentration, I can say pi is directly proportional to the temperature. Okay, the temperature maintained during the process. If more temperature, more is the pressure created. Okay, so from these together I can write Van 't Hoff equation as pi equals to, or pi is proportional to molar concentration. Molar concentration is nothing but molarity you should take into its temperature, like this. Okay, so now I am removing proportionality and replacing it with that universal gas constant R is there now, you can use that R CMST. Okay, SCMT I am writing. So sometimes it is mentioned as R, or sometimes it is also indicated with S, so you can write CMST like this. Okay, so both are same only here. So you can take R values, that universal gas constant values for R and S. So you can take in joules 8.314, joule per Kelvin per mole, you can take R, R equals to 0.082 liter atm Kelvin inverse mole inverse. Since we are talking about pressures, you can take, this will be the value you will be using here more, okay. So you can remember this thing, okay. Sometimes they will mention R or S, both are same only here, okay. So now what I am saying here is one important thing, especially for NEET students, you will be more familiar with this thing. Just look at here. See, if I say pi 1 equals to pi 2, I have two solutions, okay. I have two solutions, I can say solution 1, solution 2, okay. So both solutions are exhibiting same pressure, same osmotic pressure. I should call these as isotonic solutions. What is that? Isotonic solutions. Now sometimes what happens, solution 1 will exhibit more osmotic pressure than the solution 2, okay. So now I can say the solution which is exhibiting more pressure, I can say hypertonic, and the other one, lower osmotic pressure one, is hypotonic. This is how you can also make a note, hypotonic, okay. So now I will be telling you one more thing, you know, the saline water which is injected to the patients when a person is suffering with diarrhea or something like that. So what they will do, they will prescribe him to take saline, right now. So this saline solution contains 0.1 normal, so 0.9 weight by volume percentage concentration. So 0.9 weight by volume means what? Weight of solute in 100 ml of solution. That is what we have discussed in the concentration terms right now. So now 0.9 weight by volume is a saline water or saline solution concentration. So this is also called as normal solution, okay, normal solution, okay. So this is a concentration they will use. Why only this particular concentration, why not other? Because the blood cell, the blood fluids, the cells we have now, that blood cell containing some fluids now, that fluid concentration is also this much only, okay. So in order to maintain same concentration, and there will be no effect of this osmotic pressure when we use this. If we use other than this, what happens, there will be some effect, pressure will be created right now. So that's why this is the concentration of saline water that will be used for injecting, okay. Now one more thing, if a cell is there, see this kind of questions you will be see in the exam. So this is a cell, okay. So now this cell is placed in the solution. So this red color represent what? It is a solution having more concentration, having higher concentration, and this cell fluids having lower concentration. Just tell me, lower concentration. Now what happens? The solvent molecules moves from weight to weight. This is one of the very important aspect you need to know. So from weight to weight the solvent molecules moves. See, we know the spontaneous flow of solvent molecules from lower concentration to higher concentration takes place right now. So it means this is the lower concentration I am saying. So from here the solvent molecules, the blood fluids will goes out right now into this higher concentrated solution. So what happens? What about the size of cell now? The cell size shrinks now. It will shrinks because its body fluids, the cell fluids are coming out of that cell by the spontaneous osmosis process. So I can say in this case cell shrinks, I can say shrinks, I am writing. So other case I have, so here I have solution outside and cell inside of it. I am placing the cell now. The solution outside here I am taking is lower concentration. This is lower concentration. So in this scenario, tell me the cell with higher concentration I am saying now. So now tell me, solvent molecules will move from weight to weight in this case. See, higher concentrated inside, lower concentrated solution. I place this cell in the lower concentrated solution. Now what happens? The solvent molecules will move from this lower concentration to higher concentration. It means from outside to inside of the cell. So what happens to the cell now? So solvent molecules are entering into the cell. So cell will be expanded. I can say cell swells. So in this case it swells, okay, and even it can burst also. Okay, so this is how you can understand the applications or the effect of osmosis process in our biological aspect also. Hope this is also clear. Okay, now I will be showing few questions based on this also, just hold for some time. Okay, now what is the formula I have given? So pi equals to CMST I am writing, molar concentration, that is nothing but molarity. So this you take R value, universal gas constant values, and T is the temperature. Okay, so at particular temperature, pi is equals to, I can say pi is directly proportional to Cm only. This thing we already know from here. Okay, and for a particular concentration directly proportional to T. This already I discussed. For isotonic solution I am saying pi 1 equals to pi 2. It means C for first solution concentration C1 and S T1 I am saying. So for second solution, so C2 S T2 I am saying. So from this C1 T1 equals to C2 T2. So this is how you can use relation for the different temperatures and different concentrations of isotonic solution. This is for isotonic. Okay. Now I am asking you, let us take what is the relation between osmotic pressure with weight by volume percentage, because here if you see in the case of this 0.9 weight by volume percentage is given for the saline water solution. Now how can you calculate its osmotic pressure? So how can you calculate? So just use this formula. So pi equals to molarity I am saying and ST. So this is nothing but molar concentration, you can write Cm or M, molarity. So molarity I can write number of moles of solute by volume of solution in liters into S into T, like this you can write, or you can also convert this number of moles of solute at weight of solute. B represents solute, okay, and molecular weight of solute into, see, volume in liters I am expressing here. I want to express in liters, ml means you should take here as 1000 right now. This thing you know basically, okay, into ST. From this how can you modify this further? See, weight pi equals to weight of solute by volume of solution, 1000 I am writing it as 100 into 10 into ST by molecular weight of solute. So look at this, what exactly we can write for that? So I am writing pi equals to weight by volume percentage, nothing but weight by volume percentage, weight of solute in volume of solution. In 100 ml of solution means weight by volume percentage. Okay, so into 10 into ST by MB. So MB is nothing but molecular weight of solute. So now you need to remember this formula 1, and one more thing you can observe here, pi is inversely proportional to molecular weight of solute. Okay, so all the colligative properties in each of the 4 colligative properties we discussed. So there what you will be seeing, the colligative property here, pi is inversely proportional to molecular weight of solute. Similarly RLVP also inversely proportional. Similarly delta B or delta TF, all these are inversely proportional to the molecular weight of solute. You can remember this thing. Okay, now I will be asking you few questions based on this explanation. We'll solve these questions first. Okay, so look at these. Let me show you this first, easy question first. Okay, see, this is JEE Main 2020, very easy question they have asked. Just look at the statement mentioned question. The size of raw mango shrinks to a much smaller size when kept in a concentrated salt solution. Which of the following process explains this? So what they are saying, see, size of raw mango, let us say this is a raw mango. Okay, so now when it is placed in the concentrated solution, it means this red color represents concentrated solution and this is our raw mango. So now what happens? So high concentrated solution is outside and raw mango inside of it. So it means I can say raw mango having low concentration. This is high concentration, this is low concentration. Now solvent molecules will move from weight to weight. So they will move from this lower concentration to higher concentration right now. So spontaneously they will come out. The solvent molecules will come out. So what happens to the size of raw mango? It will compress or shrinks right now. So what process it is? Spontaneous flow means what? Yes, this is osmosis right now. So our first option for this question is correct. Hope this is clear, right? Yeah, so you can solve this kind of questions, especially for NEET students. You need to focus this kind of questions. Okay, now if it is clear, just tell me in the chat box, clear sir. Yeah, I will be discussing one more question here. A solution is prepared by dissolving 0.6 grams of urea having molar mass and 1.8 grams of glucose having molar mass this much in 100 ml of water at 27 degrees Celsius. The osmotic pressure of the solution. See, they have given a solution containing two solutes. I mean, one is urea and another one is glucose. So I can say it is a ternary solution. It contains three components: glucose, urea, water. Right now, so in this case, pi total you can take it as pi total equals to pi 1 plus pi 2. Okay, so here pi is nothing but we need to find this pi total. So pi is nothing but molar concentration. First one is urea, so concentration of urea I am writing. So U represents urea into St plus here also concentration of glucose, Cg I am writing, concentration of glucose into S into T. See, temperature is constant, both of them having same temperature now, and S is also constant. So I am writing concentration of molar concentration of urea plus molar concentration of glucose multiplied with S into T. Okay, this is pi total. Hope it is clear up to here. Yeah, so now what is this concentration they mentioned? See, they have mentioned it as 60 grams molar mass and 0.6 grams of urea taken. So number of moles of urea you can take and volume of urea, okay, plus number of moles of glucose you can take, and volume of glucose you have to take, a solution you have to take. So total volume is given as 100 ml. So when they are expressing in 100 ml, so total V's both V's are 100 only. So I can take it as and common one, 1000 into S into T. So why I am taking 1000 there? Volume is expressed in terms of ml. That's why multiplied with 1000. So I am taking these outside V here. Okay. Hope it is also clear up to here. No confusions. Right now. Now tell me number of moles given. Pi total equals to number of moles 0.6 by 60 molar mass. Number of moles of glucose is 1.8, given weight by molar mass is 180. Okay, and volume mentioned here is 100, and S value is how much? R given as 0.082 into temperature mentioned 27 degrees, can write 300 Kelvin. Right now, yeah. So try to simplify this. So I can write here 0.6 means 6 by 100 I can write, this will be 100 times. Here also 1800, this is also 100 times. Okay, so pi total will be, so 1 by 100 plus 1 by 100. Okay, and these two zeros are removed. So into 1000 into 0.082 into 3 we have. So now here I can write 2 by 100 now. Yeah, 2 by 100 into 1000 into 0.082 into 3. Okay, these two zeros removed. So finally what we have? So 2 into 0.82 into 3. So 6 into 2 3 is 6 into 0.82. So this gives us 4.92 as the osmotic pressure exerted by the solution in the terms of ATMs. Hope this is clear. Every step is explained or mentioned clearly. Okay, so yeah, I hope you can able to do any other question comes in this manner. Okay, so generally they will give only one solution, just put CST, you will get the answer. But when they given multiple solutions, like more than one component is present, like ternary, quaternary solutions are given, just use this formula, pi total equals to pi 1 plus pi 2 plus pi 3 plus so on, you can use, you will get the answer. Hope this is clear, right? Yeah, let me discuss one more question. See, one more important point you can write, osmosis or osmometry. Osmometry is a method used to calculate molecular weight of molecular weight of proteins, molecular weight of proteins or biomolecules. See, a biopolymer having this much mass dissolved in 100 ml of urea, 100 ml of water at 300 Kelvin exerted an osmotic pressure of this much. What is the molar mass of that biopolymer? So, osmosis or osmometry is used to find the molecular weight of biomolecules, biopolymers. You can remember this statement. Okay, one of the important statement it is. Okay, now what you can do? So, pi equals to molar concentration into S into T. Now, this molar concentration I can write it as number of moles of solute by volume into S into T, like this now. So, from here number of moles I can write given weight by its molar mass of that solute into S T by V, right now. Yeah, so everything is mentioned except this molecular weight, right now. Yes, now substitute these values in that formula. So what you will get? What you will get here? So you will get the answer. See, 2.42 pi is 2.42 into 10 power minus 3 bar. Okay, equals to, what is the weight they mentioned? Weight they mentioned it as 1.46 grams. Okay, and what is the molecular weight? You need to find this into S is 0.082. Okay, 83 bars, liter bars. Temperature is 300 Kelvin mentioned. Volume mentioned is how much? So see, dissolve in 100 ml. So if it is in ml, multiply with 1000. That's it. By simplifying this, you will get the answer. Just give a try. You will get the final answer from this. Okay. Hope this is also clear. This is also clear. Yeah. So now one more question I will be showing you. Yeah, who is it? Sanket. Please watch it from the beginning so that you will get everything clear. From this session only, just go from the beginning, you will get everything clear about this osmosis. Okay, and we have one more question here. The osmotic pressure exerted by a solution prepared by dissolving 2 grams of protein having molar mass this much in 200 ml at 27. Yes, based on that you can easily solve now. The osmotic pressure pi you need to calculate equals to given concentration, you need to find number of moles, you find given weight is 2 grams having molar mass 60 grams. So 2 by 60 into 10 power 3 grams you can take. This is number of moles. What is the volume they mentioned? 200 ml. So 1000 by what is the volume? 200 you can take into S value you can take. So 0.083. What is the temperature mentioned? Temperature mentioned is 27. So you can say 300 Kelvin. Okay, just use this formula pi equals to CMST. From this only you can get the final answer. Hope this is also clear. Yes, both questions you can try and solve the questions. Give me answer in the chat box. I will be looking into it. All the questions which I have discussed, either JEE mains or NEET previous year questions only. Okay, hope this session is helpful for you, and any confusions are there, feel free to ask me in the chat box. I will discuss in the upcoming sessions. Okay, hope you like the session. Just click on the like button if you really watched it completely. Thank you for watching.